Hey guys, I want to look at the next lesson on factoring, lesson 5, factoring the greatest common factor. So if we just look at that in terms of numbers, like we did in grade 7, 8, 9, you probably looked at a little bit of greatest common factor. The greatest factor that two or more numbers have in common. So sometimes we can look at two numbers and figure out the greatest common factor really quickly. Sometimes it takes a little bit more work. So there's a couple of strategies that we have that can help us. So for example, one strategy is, the first method here is called listing all the factors. So if I take the 12, okay, and I take 18, and I list out my factors. Well, the 12, I know that 12 could be written as 1 times 12. Okay, 1 and 12 are both factors of 12, 2 and 6, and 3 and 4. And some of you may have just been able to have listed those 1, 2, 3, 4, 6, and 12. That's another way, okay? Factors of 18, 1, 2, 3, 6, 9, and 18. Or you can go 1 times 18, because of course 1 times anything, 2 times 9, because it's even, and 3 times 6, because 3 times 6 is the other one that's equal to 18. So then when I look at my common factors, I can see that I've got 1, 2, 3, 1, 2, 3, and 6. So what's the greatest common factor here? The greatest common factor here would be 6. Okay? Our GCF is equal to 6. Now another method of doing this, and it works really well, it's very helpful with very large numbers, is to use prime factorization. This is the second method. So what I want to do is I want to make a factor tree. We're going to create a factor tree. And how do I do that? So I'm going to take my 12 and we're going to break that up into prime factors. So 4 and 3 make 12, and then 4 of course can break down into 2 and 2. And then if I do the same thing with 18, 9 and 2, or you could use 6 and 3, it doesn't matter as long as we break it down into the prime factors. Now what I want to do is I want to look at what is common here in my factor tree. So the common factors, there's a 2 and a 2. Okay, note I can only circle 1, 2 over here with the 12 because there's only a single 2 with the 18. So I've got a 2 here. Whoops, I didn't mean to erase all that. Okay, I just want to erase the, so I can circle 1, 2, and then there's a single 3 here, and then I can circle one of the 3's over here. So how is this going to equate to 6? Well, my greatest common factor, therefore, when I look at my prime factors, is 2 times 3, which is 6. Okay, those are the common prime factors. And so that's just another strategy that can give me the same answer. So why don't I give you a second to try and see if you can list all the common factors of 40 and 56 and try to create a factor tree for 24 and 60. So 40, I would create a little table. Okay, I would start by creating a table. And 56, I would again create a little table. And then 24 and 60, I would create 2 little factor trees, okay? And so why don't I give you guys a second to try that, or a minute. So pause the video and see if you can do that on your own. Okay, so I've listed out the factors for 40 and 56, and I've created factor trees for 24 and 60. So let's just look at the question here. I can see that 1 is common, 2 is common, 4 is common, and 8 is common. And of course, my largest common factor there then is 8. Okay, so our GCF is 8. Our greatest common factor is 8. And some of you could have just looked at 40 and 56 and said, oh, the biggest number that goes into there is 8. So that's a third strategy, just by inspection. Okay, and if you're really good at that, then that's awesome. That'll save you some heartache. Okay, and then this next one, let's look at what is common. I've got a 2 and a 2. Let's do a different color here. I've got a 2 and a 2. Oh, I've got another 2 and another 2. And then we've got a 3 and a 3. So this doesn't seem to be turning. Oh, this is a different number. I thought this was going to be 8 over again, but these are different numbers, 24 and 60. GCF there, then therefore is 2 times 2 times 3, and if I multiply 2 times 2, we get 4 times 3, which is 12. Okay, and of course 12 goes into 24 and 12 goes into 60. So there's our GCF right there. And a couple of strategies to try those. Now, if we look at the next question, it says, in each case, state the greatest common factor of the following sets of monomials. So when we're looking at these, I want to look at my numbers separate from my letters. So let's look at the numbers. Some of you may note that 3 will go into both 12 and 15. And again, if you're not sure, you can always break down, right, that into a factor tree. You're going to have to do that sort of on the side, or, you know, make a little space. And of course, oh, there's my 3, right? There's our 3 and our 3. There's our greatest common factor. So it says, what is the biggest common factor? So I'm going to look at my numbers, and then I look at the letters. Here in this monomial, in this term, 12ab, I've got a single a, and I've got 2 a's here. A times a, which is a squared. Okay, this is multiply. And then here I've got a single b, and here we've got 3 b's being multiplied. So what would be common? If I look at what's common to both of them, in this case, I've got an a that's common in both. Okay, I can't circle more than one a here in the second one because there's only a single a in the first term. Okay, and then in terms of b's, I've got a b and a b. So what is common to both of those? AB. So our greatest common factor would be 3AB. All right, let's look at question B, 18 and 24. Some of you can, if you're not sure, you can draw out a factor tree, but we know that some of us may know that 6 will go into both of those, right? I can do my 18 here, and that's 6 times 3 and 3 times 2, and then 24 was 8 times 3, 4 times 2, and 2 times 2. So in terms of what's common, I've got a 3 and a 2, and I've got a 3 and a 2. So GCF is 6, right? 3 times 2 is 6. Now, so I know my common factor there is going to be 6. Not negative, because this negative is not common, right? It's only in one of the terms. And then, of course, what is common? Here I've got an x, an x, an x, an x, and a y, and a y. X, 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 x times x times x, y times y times y times y times y. How many of those are common? I've got 3 and 3, right? I've got 4 here, but I've got 3 only in my second term. And then I've got 2 y's that are common. So I'm just going to highlight those. I've got 3 x's, right, and 2 y's. Okay, so our common factor here would be 6x cubed y squared. And if you look at the numbers, you're limited by the smallest variable. Exponent, I should say, the exponent, smallest exponent on each variable. So if I look at the x cubed, I've got x to the power 4 and x to the power 3. 3 would be my smallest one. I'm limited because that's the maximum I have. And then the 2 here for the y. Okay, that's another little hint, perhaps. If I look at question C, my coefficient in front of a cubed bc squared is a single 1. So my GCF, the number doesn't have, there's no common factor for, well, the common factor is 1. So that's not a way of reducing that at all. And then if I look at the a, my little exponent there is a 1. So a is common to both. I have an a, right? I've got an a times a times a times b times c. And then here we've got an a times c, 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 c. So what's common? A single a and 2 c's. So ac squared would be our common factor, greatest common factor there. The next one, I've got all 3 negatives, and these are all multiples of 10. So of course, my GCF is going to be negative 10. Looking at my lowest variable, I've got a squared, a cubed. So the 2 is the smallest there. All right, and then here on the second one, we've got b cubed, b squared, and this is a little b to the power of 1. So we're limited by the 1. So our greatest common factor here ends up being a squared b. Okay? Let's take a look at the next example here. Okay, let's look at the next example here. We want to look at factoring, some more factoring. So we've done greatest common factor a little bit. The greatest common factor is a number that divides into every term of a polynomial. The GCF can be a monomial or a binomial or a trinomial. So that's a little complicated, but let's just have a little example here. It says expand the following. So if I expand this, I'm going to multiply. Expand is another term for multiply or find the product. So I'm going to go 2x times x, which is 2x squared, and 2x times 5, which is 10x. Now, if we want to factor the following, what I want to do is I want to take out my greatest common factor. So what's common here? Out of 2 and 10, I know my GCF there would be a 2. And I can also look at my x and my x and my x. I can take an x out of both terms. So that's my GCF. And what I want to do is I want to divide that out. So I'm going to take, and I'm just literally going to write right underneath these, divide by 2x, divide by 2x, and I'm going to actually divide that GCF out, greatest common factor. So 2 divided by 2 is simply 1, and x squared divided by x is simply x, right? And the reason for that is that's the x times x divided by x. And these two x's here will reduce into a single x because x divided by x is 1. Not 0, but 1. Okay? And if we look at the next one, 10 divided by 2, okay, 10x divided by 2x is going to be 5 because the x's again reduce. And look what we have. Lo and behold, we're back at where we started over here. So that's the process. Factoring is the opposite of distribution. So let's do a few examples together before I give you a chance to try a few on your own. So if I look at the first example here, it says 30x minus 6. I'm going to look at my numbers separate from my letters. So if I look what is common to both 30 and 6, my common factor would be 6 because 6 goes into 30 and 6 goes into 6. When I then go ahead and divide both of these by 6, we end up, and there's no common variable, is there? Because there's an x here, but there's no x, right? There's no x here, so therefore there's no common x. When I divide 30x by 6, I get 5x, and 6 divided by 6 is a 1 with a minus sign, of course. That's a negative 6 divided by 6. Let's look at the next one, 18 and 9. 9 goes into both 18 and 9, and when I divide that out, let me just move this down a little bit. When I divide that out, we're going to divide out 9, 9, and let's look at the letters as well. In this case, I've got a common, I've got x times x times x times x, and we've got x times x here. So what's common? X squared. So we're dividing by 9x squared when we put our GCF there, and 18 divided by 9 is 2. I'm just following along here. 18 divided by 9 is 2, and x to the 4 divided by x squared is, of course, x squared, right? Because that's x times x times x times x divided by x times x. 2 of those cancel with 2 of those, and we're left with x squared. And the last term here, 9x squared divided by 9x squared, that's equal to 1, okay? Sometimes we get confused because what do we put there? Well, 9x squared divided by 9x squared is 1. And if we were to do a check, if we were to go backwards, if I were to check my answer, I would simply FOIL or multiply or distribute, whatever you want to call it, and we'll get 18x to the power of 4. So 9 times 2 is 18. X squared times x squared is x to the power of 4. And 9x squared times 1 is 9x squared. So that is our answer for sure, because that's when we multiplied it out, that's what I got to, that's what I started with. Okay, let's do the next one. 15m squared n, 18mn squared. GCF there numerically is a 3. 3 is the biggest number that goes into 15 and 18. And then I've got a common m and a common n. I'm going to literally write that down here. We don't have to do that, but I think it helps, and I want to try to teach you how to keep a little bit more organized, maybe than you have been in the past. I don't know. Probably some of you are more organized than me. So 15 divided by 3, we're going to put the leftovers inside the bracket. Once we divide out the 3, we get 5. M squared divided by m is a single m. And the ends, of course, cancel or reduce to 1. And that's a minus 18 divided by 3 is 6. m's cancel, n squared divided by n is n. So there's our factored polynomial. Let's try the next one here, 12, 9, and 3. I can take a 3 out of all of those. I can't take an a out, even though there's an a squared here and a to the power of 1. There's no a. This is a to the power of 0, really, right? A to the power of 0 is equal to 1. So there's really, I can't take out a common a. There's none of them here. So we just don't even write that. But I can take out this 3. I'll divide everything by 3, and we're going to get, sorry, not 12. 4. 12 divided by 3 is 4. A squared minus 3a plus 1. Okay, let's take a look at the next one. 10, 8, and 2, those are all divisible by 2. They're all even numbers. So I've got to add 2. I know x cubed, x and x is common. X squared, x cubed, x to the 4. Sorry, y squared, y cubed, y to the 4. Y squared is common. And when I divide everything through by 2xy squared, I end up here with 5 x squared plus 4y plus y cubed. Okay, 10 divided by 2, 5, left with an x squared. The y squareds cancel. 8 divided by 2, 4, x's cancel. 3 minus 2, that's y to the power of 1. 2's cancel, x's cancel, y to the power of, oh, that should be y to the power of 2. I just rewrote that. I just wrote that wrong. Sorry, y to the 4, which is y times y times y times y over y times y, y squared. Okay, sorry, I had a 3 written down by accident. Okay, let's look at the next one. 12, 6, and 15, all multiples of 3. Okay, largest common factor that will go into all those is 3. And I've got a p cubed, p squared, and a p, so I can take out a 3p. And when I divide by 3p, 12 divided by 3 is 4p, that's going to be p squared, 3 minus 1. 6 divided by 3 is 2, and it's a minus because it's a negative 6. And that's p squared divided by p is a single p, and 15 divided by 3 is 5, and the p is reduced to 1. So there's our GCF and our leftover factored polynomial. Okay, let's try the last one here. 25, 20, and 30. GCF would be 5. I've got a single x in that term. I've got y squared, y to the 4, y squared, so y squared can come out of all of those. Z cubed, z squared, z to the 5, z squared can come out of everything there. So when we divide out by 5x y squared z squared, and again, sometimes it just helps to kind of look and see these right underneath each term. When I simplify or divide those out, we get 25 divided by 5, 5, x is reduced, y squared is reduced, we get z cubed divided by z squared, minus 4, okay, x squared divided by x is x, y to the 4 divided by y squared, and the z's reduced to 1. And 30 divided by 5 is 6, x to the 4 divided by x to the 1, x cubed, y is reduced, and then z to the 5 minus 2 is z to the power of 3. Yikers! That's a lot of work, that one, okay? A lot of numbers there, a lot of variables. Okay, if you would like to give these a try, I would recommend it. Give yourself a second here, pause the video, try these, and then come back and check your own answers. Okay, so for these answers, this is what I got. If you want to pause the video and check your own work there. All right, and if you want to look at the assignment, this is lesson 5. If you want to look at the assignment for lesson 5, you could do anything, sorry, I'm just bopping to make sure it's lesson 5. You could do anything from numbers 1 to 8, okay? That would be a good start. You're free to do more, but I would say any of those ones would be perfect. Thank you, and please do not hesitate to contact me if you have any questions.